Let's look into the external anatomy of the kidney. Kidneys lie on either side of the spine in the retroperitoneal space between the parietal peritoneum and the posterior abdominal wall, well protected by muscle, fat, and ribs. They are roughly the size of your fist, and the male kidney is typically a bit larger than the female kidney. Each kidney weighs about 125 to 175 grams in males and 115 to 155 grams in females. They are about 11 to 14 centimeters in length, 6 centimeters wide, and 4 centimeters thick. The left kidney is located at about the T12 to L3 vertebrae, whereas the right is lower due to slight displacement by the liver. Upper portions of the kidneys are somewhat protected by the 11th and 12th ribs. The kidneys are protected by a fibrous capsule composed of dense, irregular connective tissue that helps to hold their shape and protect them. This capsule is covered by a shock-absorbing layer of adipose tissue called the renal fat pad, which in turn is encompassed by a tough renal fascia. The fascia and, to a lesser extent, the overlying peritoneum serves to firmly anchor the kidneys to the posterior abdominal wall in the retroperitoneal position. Now let's look into the internal anatomy of the kidney. A frontal section through the kidney reveals an outer region called the renal cortex and an inner region called the medulla. The renal columns are connective tissue extensions that radiate downward from the cortex through the medulla to separate the most characteristic features of the medulla, the renal pyramids, and renal papillae. The papillae are bundles of collecting ducts that transport urine made by nephrons to the calyces of the kidney for excretion. The renal columns also serve to divide the kidney into 6 to 8 lobes and provide a supportive framework for vessels that enter and exit the cortex. The pyramids and renal columns taken together constitute the kidney lobes. Why is it important to take good care of your kidneys? Firstly, when working properly, kidneys produce important hormones. These hormones regulate bodily functions like blood pressure, the uptake of calcium and the creation of red blood cells. Next, it helps prevent chronic kidney disease. Chronic kidney disease, CKD, happens when there are damage causing decreased kidney functions for a period of 3 months or longer. The kidney also plays a big role in removing waste products as well as regulate blood pH. This means they must remove excess minerals, like potassium and sodium, which are then excreted in the urine.
Now, let's take into account the various preservation methods of organs. First of, silicone plastination. Silicone plastination includes plastinated samples from real-life bodies, thus having high educational values, and to be kept in museums or universities. Silicone plastination keeps the specimen in its natural form for a detailed display, that is odorless, durable, flexible and keeps the sample at its original size, non-shrinkable. Next up, sheet plastination. Sheet plastination involves 2 distinct methods, which are the epoxy method and polyester method. This plastination method requires 1 to 5 mm thick of sliced plastinated samples from real bodies. The sample's bodily liquid will be replaced with polymers, allowing an illustration of anatomical structures to be easily observed. The plastinated sample will have a transparent or translucent appearance with colors and does not decay over time. It can also be observed to its microscopic level, which has more specificity of various tissues found in the sample. Lastly, wet specimens. Wet specimens are also known as canopic jars, when the method was used back in the Pharaonic period. The method requires organs to be injected and soaked with fixative solutions such as formalin and to be placed in glass jars for further hardening. Specimens are to be handled with extra care and exchange of specimen solution every month is compulsory, in order to keep the specimen in shape and not rot over time. Plastination involves 4 stages, which are specimen preparation, where the specimen is sanitized properly, dehydration plus defatting, where bodily fluids are extracted out, and any foreign substances are to be cut out, forced impregnation, where polymers are to be penetrated into the organ cells, and curing, where gas, light or heat allows hardening of the organ. Now that you have the gist of plastination methods, let's move on to explore the macro and micro anatomy between a healthy preserved kidney with a diseased one. Here we have a healthy preserved kidney, and a hydronephrotic kidney found in the Anatomy Museum. Let's first look into the macro anatomy of each, which involves comparing both types of plastinated kidneys in a large-scale perspective. In this healthy preserved kidney, it is preserved using silicone plastination, which helps retain the kidney's original size, almost the size of a fist. We can see that the renal cortex is smooth. The renal pyramids have its defined shape, which is seen very clearly. Other visible structures can be the major and minor calyx, renal columns, with the renal artery and veins removed. On the other hand, the hydronephrotic kidney uses sheet plastination, where the whole kidney has been split open. Comparing it to the healthy kidney, the hydronephrotic kidney has expanded greatly, with a bumpy or uneven superficial surface due to hypertension. The renal cortex is uneven and the renal medulla is in definite shape. Unlike the structures in the healthy kidney, the major and minor calyx have been enlarged, distortion has happened in the renal columns, and the renal artery and veins have enlarged and swollen. Moving on, let's look into what goes on inside the cells, hence the microanatomy, where we compare the healthy and hydronephrotic kidneys in a smaller scale perspective. In the healthy kidney, we can see the renal pelvis is down to its normal size, with a thick layer of renal medulla, and a normal conditioned ureter. However, in the hydronephrotic kidney, the renal pelvis is enlarged and dilated drastically, thus causing the renal cortex shape to develop distortion. The renal medulla became a thin layer, with the ureter seen bursting. From this, we can learn a lot about the various structures of kidneys by being able to observe it with your own eyes. It is encouraged to have an anatomy museum with such various preserved organs in various medical conditions, in order to understand and broaden our knowledge, comparing with what is seen in lectures versus actual kidneys found in real life. So, 2D learning versus 3D learning. Which works better as an educational resource for student to study anatomy? What is 2D learning and 3D learning? So, let's jump right into it. What is 2D learning? Firstly, 2D learning. So, 2D is a hand-drawn animation or diagram. 2D learning also provides students with a basic knowledge of the various structures. Basically, 2D learning is using a diagram that has the structure of the kidneys with name labels. Next. What is 3D learning then? 3D gives a realistic texture of the organ. 3D learning provides a better observation of the organ. You can do this by turning the plastic model of the organ around or even open it to view the organ more detailed. A few examples of the model we can use for 3D learning are the plastinated organ and the preserved organ in the jar. So what is the pros and cons of 2D learning and 3D learning? Let's start off from the pros of 2D learning. So the pros of 2D learning are 2D is much simpler and easier to use, and the cons of it are 2D animation now is considered older and less interesting to see. Moving on to the pros and cons of 3D learning. The pros of 3D learning are 3D provides realistic yet detailed graphics with the cues on visual, auditory and spatial elements of 3D environment. The cons of 3D learning are the physical side effects like nausea, headache and more. That leads to worse task performance. To conclude this, results show that students working with 3D vision achieved significantly better results than students who worked in 2D. 95% of the students filled out the questionnaire, and over 90% preferred 3D vision. Please notice that everyone has different ways to learn, therefore some prefer 2D learning and some prefer 3D learning.